C3 Trigonometry 2 example 13. Solving a trig equation where one of the angles is a double angle and the other one is a single angle. The first task is to make them consistent, either both double angles or both single angles. What I'm going to use is one of the identities for cos of 2x. I'm going to use the one that only has cosines. So that's 2 cos squared x minus 1. That's what I've replaced cos of 2x with. I use that version because the other term in this equation that has trigonometry is a cosine term. So that's why I used the one with cos squared. So this started off as a C3 question because we had a double angle and a single angle. It's now effectively a C2 question. A tricky one, but still C2. Let's get rid of the brackets. So it's 6 cos squared x. I'm going to tidy it up as well at the same time. So that minus 3, I'm going to wait and write it later with the plus 2. So it'll be 6 cos squared x minus cos x. And that minus 3, if we combine it with the plus 2, gives us minus 1. So as you can see, it's a quadratic in cos x. Effectively now, like I said, this is a C2 question from here on. So if it factorizes, we factorize it. If it doesn't, we'd use the quadratic formula. This one does factorize. So it's going to be 1 at the end of each bracket. And to give me my minus cos 2x in the middle, that will need to be a minus, and that one will need to be a plus. This gives us two possibilities. Either cos x is minus a third, or cos x is a half. So two possibilities here. I need two cast diagrams. First of all, let's do cos x equals minus a third. So here's the cast diagram. This question's in degrees. So if I put in degrees on my cast diagram. Right, if cos x is minus a third, that means the solutions will lie in t and s. Those are the only places where cos is negative. So draw the line on there. The angle that those lines make with the horizontal, I'm going to call it alpha. And then alpha would come from the calculator. It'll be the inverse cos, or arc cos, of a third. I recommend you don't put the minus in your calculator. It just makes things easier. We've effectively dealt with the minus when we circled the s and the t. So inverse cos of a third. I'm going to give my final answers to one decimal place. So that's 70.5 degrees. So the two solutions from this possibility are x is, so measuring from 0 on the cast diagram, that first angle there, which is going to be 180 minus 70.5, so that's 109.5 degrees. And the other one, again going back to 0 on the cast diagram, will be 180 plus alpha. So 180 plus 70.5, 250.5 degrees. I've rounded those to one decimal place. Let's go ahead and find the other two solutions coming from cos x equaling a half. So this time on the cast diagram, cos x equals a positive number. So the solutions will be in A and C. The method is the same every time. Draw a line in each section, and the angle that those lines make with the horizontal, I like to call it alpha, and then alpha will be inverse cos or arc cos of a half, which you should know really is 60 degrees, or you can always use calculator to check. That'll be 60 degrees. So the two solutions in this possibility, 60 degrees, and the other one is almost all the way around, but except for 60, so it's 60 degrees and 300 degrees. This time those were not rounded, they were exact. The other two were rounded to one decimal place. So remember what we found here, we found the values of x which make this equation work. So if you've got time in the exam, you can always put them back into the equation and see if you get 0. If you do, then you know you've got the right answers.